In this problem, we have an equation with two square roots, and we're going to solve for x. So whenever you have an equation with square roots, you want to isolate the square roots and get rid of them by squaring both sides. So we'll start by subtracting this piece here, this square root of x minus 6. So minus the square root of x minus 6 minus the square root of x minus 6. These cancel. So we're left with the square root of 2x plus 5, and that's equal to 3 minus the square root of x minus 6. Okay, so now we're ready to get rid of the square roots. So to do that, or at least the square root on the left, so we'll square both sides and square this side. So on the left, we're left with 2x plus 5. And then on the right side, one way to do it is that whenever you see a 2, just write it twice. So 3 minus the square root of x minus 6, and then just write it again. 3 minus the square root of x minus 6. Good stuff. So this is 2x plus 5. And then here on the right-hand side, we can just distribute. So we take the 3 and then multiply it by both of these, and then take the square root, multiply it by both of these. So 3 times 3, that's 9. And then 3 times this would be minus 3 square root x minus 6. It's really FOIL. First, outside, and then you do inside. And then the last one is last. Maybe that's why it's called last. Negative and negative is positive. And then the square root of x minus 6 times the square root of x minus 6 is just x minus 6. The square roots go away when you do that. It looks like we have some like terms on the right-hand side. So let's go ahead and bring this one down again, 2x plus 5. And let's go ahead and collect like terms here. So we have 9 minus 6. That's going to give us 3. And then we have minus 3 square root x minus 6. Minus 3 square root x minus 6. It's going to give us minus 6 square root x minus 6. And then we still have the hanging x over here. So plus x plus x. All right. So we still have square roots. So we have to get rid of them. So we need to isolate this piece. That means we need to subtract the 3. Boom. And we need to subtract the x. Boom, beautiful stuff. 2x minus x is x. 5 minus 3 is positive 2. And that's equal to minus 6 square root x minus 6. Oh, this is interesting. A little bit harder than I thought it would be. So there's a minus 6 here. And so I did say we should solve for the square root. However, if we divide by minus 6, what's going to happen is we're going to end up getting a fraction. So let's avoid that. How? Well, let's just go ahead and square everything right now. And we can do that. We can just square both sides like this. So on the left-hand side, we now have x plus 2 squared, which basically means we write it twice. X plus 2, x plus 2. And then here, properties of exponents say that we basically square each piece. So we square the negative 6. That's going to give us 36. And then you square the square root. That gives you x minus 6. So you square each piece. Here's the missing step that I didn't show. I'll do it on the side here. You square the 6, and you square the x minus 6. It's more work to show the step than it is to do it. That happens a lot in math. So 36, x minus 6. Boom. All right, let's distribute stuff. So x times x is x squared, and then x times 2 is 2x. Then you go to the next one. 2 times x is 2x, and then 2 times 2 is 4. Did that kind of fast, foiling. And then here we distribute. 36 times x is 36x. And I think 36 times 6 is 216, but let me just quadruple check. I'm like 99% sure. Yep, 216. 216. Just didn't want to mess up this far into the video. Like, no, start over. So let's combine like terms. X squared 2x plus 2x is 4x. And then we still have the 4. And then here we have 36x minus 216. So this is a quadratic equation. So in general, like in math, when you have a quadratic equation, there's a bunch of ways to solve it. But pretty much all of those ways usually involve first setting it equal to 0. So let's go ahead and subtract the 36x and add the 216. Oh, this is going to be some fun factoring. So plus 216. This is going to give us x squared minus 32x plus 220, and that's equal to 0. Okay, so now we have to attempt to factor this. So 220, wow, what multiplies to 220? Let's think. Well, I'm thinking really basic here, but 10 and 22, that's going to give us 220. Again, now as we do this, we're trying to think of what can we add to get negative 32. So like 10 times 22 will give us 220. That's an option, right? Another option here for the 10 is 2 times 5, and we can't break it down any further. And then for the 22, we get 11 and 2. So this is, I think this is called like a factor tree, I believe is the name for 220. So now we can try to think about like, okay, how can we get 32? I think, well, 22 times 10, oh, that's going to give us 32. We didn't even need to go that far. Wow, that'll work. So here we go. So 22 and 10, right? So I didn't even need to do all this. And they both need to be negative. Interesting though, you see I start the factoring process and I keep going and it's right there. So a lot of times that happens with factoring. You know, if you don't do a lot of factoring, maybe you're a little bit rusty, so that's okay. Eventually you figure it out. Just, you know, take the time you need to go through it. You have a product equal to 0, so you set each factor equal to 0. So x equals 22 and x equals 10. All right, so now we should check our answer. Whenever you have an equation with roots, like we do here, 2x plus 5, x minus 6, let me write it down. 2x plus 5, and then it was, I think it was plus, is it plus square root of x minus 6? Whenever you have one of these, you should always check your answer. So always plus square root x minus 6. And I believe it was equal to 3. Let me just double check one more time. 2x plus 5, x minus 6, and 3. Yup, looks good. So always, so equations with square roots, it's super important to check. So I doubt both of these are going to be answers. So now we're going to plug them into this. So let's check 22. So we have the square root of 2 times 22 plus 5 plus 22 minus 6, and that should be equal to 3. So this is going to be 2 times 22, okay, 2 times 22 is 44, plus 5 is 49, skipping some steps here, plus 22 minus 6 is 16, and that should be equal to 3. 7 plus 4 is equal to 3. 11 is equal to 3. No, that's definitely not correct. So no good. Let's check 10. Let's check 10. So plugging in 10 now. So check 10. Square root 2 times 10 plus 5 plus, and then square root 10 minus 6. This is a long problem. You know, when people learn this, this is like typically one of the longest problems they do in whatever class they're taking. It's always like, oh wow, the 2 square roots, it's tough. 20 plus 5 is 25. And then 10 minus 6 is 4. That should be equal to 3. So 5 plus 2 is 3. Almost messed up. So 7 is equal to 3. No. So none of these check. Well, that means we have no answers. So the answer is no solution. So there is no solution to this problem. If you're looking for the solution set, like if the question is asking you for that, it would be this set here. This set here is called the empty set. And it's called the empty set because it's empty. There's nothing in it. It's the set with no solutions. The symbol that we use in math for the empty set is this one. So kind of a tough problem, and as you see, it took me a little bit to figure out the factoring. You know, I wrote the numbers down, and it just wasn't obvious. I didn't think that, you know, when you add these, you get negative 32. That happens to me all the time, and it's normal. So it shows that you don't have to be like a master at factoring, and you can always, you know, do trial and error and work through it. So if this doesn't factor, you did it wrong. That's why this step is so important. So if you get stuck here, keep trying. And if you really think it doesn't factor, then you made a mistake somewhere else. Typically, this will always factor every single time. Once you factor this, you know you're going to get it right. I hope this video has been helpful. Good luck.